Very good morning, one and all. My name is T. Rajita, lecturer in ECE Government Polytechnic, Mamnath. So I am dealing with third semester and I am taking network analysis. Now I am going to discuss the topic, that is definitions of junction, branch, loop, and what are the limitations of Ohm's law and Kirchhoff's law. So the basic objectives now I am going to discuss in this class: definitions of junction, branch and loop in circuits. So what is a junction or node, branch, loop or mesh? And once you know these definitions, now I am going to discuss the limitations of Ohm's law and how to overcome to these limitations and what type of law we are using. Now that is the Kirchhoff's current law and Kirchhoff's voltage law. So what is the circuit element? An individual component which makes up the circuit is called circuit element, and it possesses two terminals, and it can be a resistor or inductor, a capacitor, a voltage source, a current source, etc. In any circuit, there may be a resistor or inductor or capacitor, voltage source or current source. With these only we are making a circuit. A circuit is interconnection of circuit elements. In a circuit, a node is there. A point node means a point in a circuit where the terminals of two or more circuit elements are connected together. Then that point is called node. Any two points which are short circuited represents same node. Junction. If three or more circuit element branches are connected together at a node, then the node is called a junction or essential node or principal node. So the branch. A path connecting any two nodes may have one or more elements. It may be a number connected in series. That is called branch. A loop. A set of branches forming a closed loop which passes through a known node more than once. That is called loop. Again I am repeating. A set of branches forming a closed path which passes through no node more than once. The closed path which originates from a particular node terminating at the same node, traveling through various other nodes without traveling through any node twice. That is called a closed path. Mesh. A loop which does not contain any other loop or loops within it is called mesh. See, this is the circuit, and this, it is having 6 branches and 4 nodes here. What are the nodes? A, B, C, D are the 4 nodes and 6 branches are there. A node is formed by connecting the branch R1, R2 and the voltage source E to 0.5. These three are connected at a point A, that is called the node A. And node B in the circuit is R2 and R4 and R5. Three resistors are joined at a point that is called node B. And node C. In this, R4 and R5 and R3 E2.5, these three are connected at a point C. See here, R3 and R4 and R6, three are connected at a point C, that is called as node C. And last node, that is the principal node, here R5, R6 and E1.5, that is voltage source 1.5, all three are connected at a point D, that is called a principal node D. These are the four nodes, and there is a 6 branches. See here, between the nodes, whatever that is connected, that is called as branch. Between A and D, there is a branch, that is R1.1K and E1.5 is connected. That is one branch. And E2.5 and R3 is connected between the nodes A and C, that is another branch. And R5 1.7K is connected between B and D, and it is another element, branch element. Hence, the circuit element that is connected between C and D is RC, and it is also called a branch. And between A and B, there is a resistor is connected, R2, and it is also called a branch. And between B and C, there is R4 is connected, it is another branch. Like this, there is a 6 branches and 4 nodes are there in this circuit. Now in the same circuit, there are the number of loops are there. See here, A, B, D, C is connected like this. There is a 4 nodes, all nodes are in only at one time it is coming. So this is a complete circuit and it is a closed loop and it is the mesh. Here there is a 6 possible loops are there. Here in that circuit we can connect these 4 loops in 6 possible ways. These are the shown here. So the in all 6 loops there is a nodes are only once it is coming. So this is about the branch elements and loops, measure, junctions, nodes. Now I am going to discuss about the Ohm's law. So in an electrical circuit at constant temperature, the current passing through the conductor between 2 points is directly proportional to the potential difference across the 2 points and inversely proportional to the resistance between them. That is, the mathematical equation that describes is I is equal to V by R. I equal to V by R. So where I is the current in amperes, V is the potential difference between the 2 points in volts, and R is the circuit parameter and measured in ohms, which is equivalent to volts per ampere and is called the resistance. See here in the figure, there is a voltage V1 is applied, that is across a resistor R1 1 kilo ohm, and there is a current passing through this resistor, that is I, and the I is equal to V divided by R. So in that way we can calculate the current. This is the basic Ohm's law. See, for example, in these circuits, a battery 18 volts is connected across a bulb. That bulb is having R is equal to 3 ohms and the battery is 18 volts. So from this figure, we can calculate that chi is equal to V by R, that is 18 by 3 is equal to 6 amps. So battery is connected across the bulb. The current flowing through the bulb is 6 amps. And you take another battery, that is 36 volts, and it is connected across the same bulb, that is R is equal to 3 ohms. Then the current flowing through that bulb is 12 amps, because I is equal to 36 by 3, that is 12 amps. That means here, by seeing these two cases, if the applied voltage is doubled from 18 volts to 36 volts, the current is also doubled because R is constant, and the current is doubled from 6 amps to 12 amps. So the current and voltage characteristic is linearly proportional. See here, like this. This is the ideal situation. It obeys the Ohm's law. In reality, resistance of filament lamp changes with changes in temperature. Ohm's law is not applicable in this situation. So Ohm's law not applicable for non-linear devices. So wherever this Ohm's law is not applicable, then we are going for Kirchhoff's laws. Kirchhoff current law. This Kirchhoff current law states that the algebraic sum of currents in a node is equal to 0, or the currents entering into the node assumed negative and current leaving the node assumed positive. The net current is equal to 0. This is the Kirchhoff's current law. See here, one junction is taken here or one node is taken here. At this node, these 4 elements are connected, that is R1, R2, R3 and R4 connected at a node, and the currents entering is through R1 and R2, that is I1 and I2 are entering into the node, and the current I4 and I3 are leaving from the node. So from this Kirchhoff's current law, we can easily tell that the current entering is equal to the current leaving, or the algebraic sum of all the currents at the node is equal to 0. The current entering is means negative and current is leaving is positive. We are assuming that the current entering into the node is negative and the current leaving from the node is positive. So that then by KCL minus I1 minus I2 plus I3 plus I4 is equal to 0. And or we can easily tell that I1 plus I2 is equal to I3 plus I4. So I1, I2 are the currents that is entering into the node. I3 and I4 are the currents that is leaving from the node. So the sum of the currents entering the node is equal to the sum of the currents leaving the node. Now I am going to explain about Kirchhoff's voltage law. These are very important laws, Kirchhoff current law and Kirchhoff voltage law. By using this only we have to analyze the circuits. See, in this Kirchhoff's voltage law, it states that the algebraic sum of voltages in a closed path is equal to 0. Again repeating, the Kirchhoff's voltage law states that the algebraic sum of voltages in a closed path is equal to 0, or the voltages rise assumed positive and voltage fall assumed negative. So, by this, in a loop, the algebraic sum of voltages in a closed path is equal to 0. So, if the circuit is traced in the direction of current I, then in the closed path, A, B, C, D, E, F, G, A. See here in this figure. See, in this, the closed path A, B, C, D, E, F, G, A. It is a closed path. And this, the algebraic sum of all the voltages in the closed path is equal to 0. According to Kirchhoff's law, all these is equal to 0. See here, in this, the E15 and E25 is the voltages rising. And voltage is falling in the circuit is the voltage across R1 and voltage across R2 and voltage across R3 and voltage across R4 are the voltages falling. The voltage across R1 is IR1 and voltage across R2 is IR2 and the voltage across R3 is IR3 and voltage across R4 is IR4 and voltage across R5 is IR5. These 5 voltages are false and the voltages E1.5 and E2.5 are that is the voltages across the voltage source. That is the voltage in voltage source is rises. That is positive. By Kirchhoff's voltage law, by applying the Kirchhoff's voltage law for the circuit, we can easily tell that E15 plus E25 minus IR1 minus IR2 minus IR3 minus IR4 minus IR5 is equal to 0. So from this, we can conclude that E15 plus E25 is equal to IR1 plus IR2 plus IR3 plus IR4 plus IR5. So, from the Kirchhoff's voltage law, the total algebraic sum of all voltages is equal to 0, or the voltage sources, that is voltage falls is equal to voltage rise. That is, the sum of voltage rises in a closed path is equal to the sum of voltage falls in that closed path. So this is about Kirchhoff's voltage law and Kirchhoff's current law. So from this we discussed about the basic definition of electric circuit and limitations of Ohm's law and laws of circuit analysis. That is, what are the laws? Kirchhoff's voltage law and Kirchhoff's current law. So just I am repeating that again. There is a Kirchhoff voltage law and Kirchhoff current law. In Kirchhoff voltage law, this algebraic sum of all the voltage drop across the closed loop is equal to 0. In Kirchhoff current law is the algebraic sum of currents in a node is equal to 0. These are very important. These two are very important and used for analyzing the circuits. Now there is a quiz questions. See here, Ohm's law applicable for linear devices, non-linear devices. So which one it is applied? The answer is linear devices. It only applicable for linear devices, and this Ohm's law is not applicable for non-linear devices. And Kirchhoff's voltage law is an algebraic sum of voltages in a closed path is equal to 0, and algebraic sum of currents in a closed path is equal to 0, and the algebraic sum of currents in a node is equal to 0. So, in which one is correct? See here, again I am repeating. The Kirchhoff voltage law is algebraic sum of voltage in a closed path is equal to 0. And B, the algebraic sum of currents in a closed path is equal to 0. And C, the algebraic sum of currents in a node is equal to 0. Which one is correct? The answer is A. That is, algebraic sum of voltages in closed path is equal to 0. The answer is A. And the algebraic sum of voltages in a closed path is equal to 0. The Kirchhoff current law. Now, the algebraic sum of voltages in closed path is equal to 0. And the algebraic sum of currents in a closed path is equal to 0. And the algebraic sum of currents in a node is 0. See, I am again repeating here. Kirchhoff's current law is algebraic sum of voltages in a closed path is equal to 0. And algebraic sum of currents in a closed path is equal to 0. And algebraic sum of currents in a node is equal to 0. See here, which one is correct? The algebraic sum of currents in a node is equal to 0. This is the answer. So now the questions. Define the following terms. Junction. What is a junction? Junction is a 3 or more circuit elements are connected at a point is called a junction. Branch. And between two nodes, the elements two or more numbers or one number more numbers can be connected between a two nodes. That is called a circuit element or a branch. Branch is called as the circuit element connected between two nodes is called branch. And loop, and that is the loop is the all the circuit elements in a closed path is equal to loop. And explain the Ohm's law and mention in its limitation. So Ohm's law is nothing but the voltage is proportional to the current and resistance, or the current flowing through a resistance is proportional to the voltage and inversely proportional to the resistance. That is the Ohm's law. But it is used for only linear applications, and non-linear applications it cannot be used. So that the limitation is it cannot be applicable for non-linear applications. Explain Kirchhoff law with examples. So already we discussed the Kirchhoff law. There is two types. One is Kirchhoff current law and another is Kirchhoff voltage law. And we have to explain this. Thank you.